Hello, Djordje Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In previous videos, we defined the concept of air parcel. We defined first law of thermodynamics, and we said that processes can be adiabatic and diabatic. And sometimes students confuse all these three. How is air parcel related to adiabatic or diabatic processes? So I decided to have entire video in which I will describe that so there is no confusion. Before we start, please make sure to like and subscribe and leave a comment. Let me know how you enjoy these videos. So here we have our parcel of air that we are studying. It's an imaginary volume of air that has any shape that suits our problem. Let's say this spherical shape. This parcel of air has temperature T, pressure P, and density ρ. And in my video on the air parcel definition, we said now we are usually interested at asking question, what will happen as this parcel of air is moving around? Now, moving around already means that this parcel of air can have some velocity v, velocity is vector, so it can move around and whatnot. So the concept of air parcel goes beyond thermodynamics. We also use it to discuss forces, as we will later in this course. For example, there could be force of gravity, gravity. There could be force of gravity acting on this parcel of air and so on. And these are not necessarily directly related to first law of thermodynamics or second law of thermodynamics. So the air parcel concept extends beyond applications to thermodynamics. But it is often used in thermodynamics. How? Well, you know from my previous video that first law of thermodynamics says that heat supplied to this parcel of air is used to increase its internal energy, namely to increase temperature, and also this parcel of air then can do some work. Where all these quantities are defined in previous video, perhaps alpha is confusing. Alpha is simply 1 divided by density. Now, we said that process is adiabatic if delta Q equals 0. And process is diabatic if delta Q is not equal to 0. Remember, it can be positive or negative, because energy can also be extracted from this parcel of air, or heat rather can be extracted, not just added. When delta Q is not 0, this is called diabatic process. Now, listen very carefully, because there is one common point of confusion. Often people think, if I do not, let's assume that I do not add or I do not remove any amount of heat, namely delta Q is 0, then that exclusively means that process is adiabatic. Not quite. Listen carefully. Even if the heat is produced within this parcel of air, that is still then diabatic process. In other words, heat doesn't have to cross the boundary of this parcel of air for process to be diabatic. If heat is generated within, the process is still diabatic. You might say, what could produce heat within this parcel of air without heat coming from outside? Answer: there is water vapor in this parcel of air. If water vapor condenses, you know from my videos on moisture that condensation will release heat, latent heat of condensation of water. So, if we have water vapor, and this water vapor condenses, forming liquid water, then there will be amount of heat released, and that heat came from within. It did not cross the boundary. that is still diabatic process. That is thermodynamically, that is still diabatic process. Because first law of thermodynamics doesn't say here, oh, this heat crosses boundary, doesn't crosses boundary. Doesn't matter. It just says heat. Whether heat came from outside or within, the process is diabatic. Now, I understand that in some books, these processes are known as moist adiabatic processes because they are so common in atmospheric sciences, namely water vapor so commonly condenses to become liquid water or liquid water evaporates to become water vapor, that there is often term moist adiabatic process. What does that mean? That means if I exclude phase changes of water, everything else is adiabatic. One more time. Strictly physically, thermodynamically, this is diabatic process. But we would sometimes unofficially say moist adiabatic. That means if I exclude phase changes of water, there is no other contributors to heat addition or removal. Okay? I hope I removed now these confusions that sometimes exist. And I will also use term moist adiabatic process. And I will have entire video devoted to that. But I want you to understand what we mean by that. Now, you might say, what are other examples of diabatic processes or classical diabatic processes where, for example, heat is added to this parcel of air and this becomes positive? Let's list some of them. Solar heating. So sun is somewhere there shining, and this shining sun brings amount of heat associated with solar radiation. That's typical diabatic process. Then surface heating. Namely, somewhere here is the Earth's surface, and the surface is heating this parcel of air through the process of, let's say, conduction, which I discussed in great details. So surface heating, as well as solar heating, are diabatic processes. If we have turbulence mixing, and this turbulence mixing brings warmer or colder air into this parcel of air, then that's also a diabatic process. If turbulence mixes air that is of same temperature, pressure, and density as the air in this parcel of air, then turbulence by itself is not diabatic or adiabatic process. Turbulence is diabatic process only if this air that is brought in has different temperature, pressure, or density, because in that case it changes heat composition of this parcel of air. So turbulence can be diabatic because pretty much every time there is that mixing, there is some change of these variables. So turbulence is also often diabatic process. And of course, diabatic process is phase changes of water. Let's say condensation, evaporation, sublimation, deposition, and so on. Okay? I hope this removes these confusions between the concept of air parcel and first principle of thermodynamics applied to adiabatic and diabatic processes in the atmosphere. Please make sure to like and subscribe. I really appreciate when you leave a comment and tell me if this was useful or what I should address perhaps in one of the next videos. In the next video we will discuss, what are we going to discuss? Oh, yes, we are going to discuss adiabatic expansion of air. Because now you might say, if this is equal to 0, what can happen? There is nothing to happen. If there is no heat added or removed from parcel of air, what can happen? It's boring. It's not boring. many things can happen without heat being released or acquired. And that's what we are going to discuss in the next video. Until then, farewell.